Have you ever wondered how pilots control an airplane? It all boils down to a system of controls designed to allow the pilot to maneuver the aircraft in flight around three axes. The moments, or rotational forces needed to achieve this, are generated by altering the airflow around the lifting surfaces, changing their shape or position. The control surfaces that the pilot can move are usually movable surfaces near the ends of the wing surfaces. This positioning provides a larger lever relative to the center of gravity, creating a larger arm moment and greater control effectiveness. There are typically three types of main control systems. The elevator for longitudinal or up and down control, achieved by moving the control stick forward and backward. The ailerons for lateral or side-to-side control, achieved by moving the control stick side to side. And the rudder for directional control in angular turns, controlled by the rudder pedals. So in essence, pilots use three primary control systems to maneuver an airplane. Now let's delve deeper into the first control system, the elevator. This essential component of aircraft control is manipulated by the pilot through the forward and backward movement of the control stick. Picture this. The pilot pushes the control stick forward. This action forces the elevator down, which in turn pushes the nose of the aircraft downward. Conversely, when the pilot pulls back on the control stick, it moves the elevator upward, causing the nose of the aircraft to rise. This might seem a bit counterintuitive initially, but over time, these movements become logical and instinctive to pilots. They become second nature, like steering a bicycle or navigating a car. So, you see, the elevator plays a pivotal role in controlling the aircraft's ascent and descent, making it a crucial part of the overall control system. That's the elevator for you, a crucial part of aircraft control that dictates the aircraft's ascent and descent. Moving on to the second control system, the ailerons. Ailerons, typically positioned at the trailing edges of each wing, play a pivotal role in controlling the aircraft's lateral tilt or roll. They work in a fascinatingly coordinated manner, moving in opposite directions to each other. As the pilot moves the control stick sideways, one aileron rises while the other descends. This operation affects the lift generated by each wing. When an aileron is raised, the lift on that wing decreases, and when it's lowered, the lift increases. This differential in lift causes the aircraft to tilt or roll towards the side of the lowered aileron. The greater the tilt of the control stick, the more pronounced the aircraft's roll becomes. It's this delicate dance of control and response that allows the pilot to steer the aircraft with precision. So the ailerons control the aircraft's tilt, making them an essential part of the aircraft's control system. Finally, let's talk about the third control system, the rudder. The rudder is key in controlling the aircraft's direction during angular turns. Now here's an interesting fact. Any increase in airflow, such as that created by the propeller, makes the rudder more efficient. This is because the airflow from the propeller spirals around the fuselage, hitting one side of the vertical stabilizer at a different angle than the other. In effect, this spiraling airflow creates a differential pressure that aids in the turning of the aircraft. However, it's not as simple as it sounds. If there's a change in the airflow acting on the vertical stabilizer and the rudder's direction needs to be adjusted to maintain balance. This is particularly noticeable at high engine power and low airspeed, like during takeoff. There you have it, the rudder, the third crucial control system that pilots use to guide an aircraft's direction.